This is a presentation of easy microgrids, especially for the Texas Smart City Summit that is occurring this week. So basically, I want to discuss a new concept based on my history of being involved with sustainability and resilience related to energy grids and large-scale energy production that started in 2012 when I was the CFO for a large project with the city of New York and a private group to develop a large-scale entertainment project in a flood zone. And I learned a lot about sustainability and resilience and energy production through that project, and have spent the last 9 years continuing to learn and explore this concept. And microgrids are an area that I've been involved with since 2012 and have figured they are really a solution for the large-scale grid problem that we are experiencing. As some of you may know, there are 3 main grids in America or in the US, and they are basically the Eastern grid, the Western grid, and the Texas grid known as ERCOT. So let's look a little bit about easy microgrids and what they are, these microgrids. The definition is a self-sufficient energy system that services a defined geographic area, and it can source power from any number of energy sources such as solar panels, fossil fuels, wind turbines, generators, battery storage, and then they distribute that energy through the defined geographic area. And the reason I got interested in microgrids was our Snowmageddon event from Winter Storm Uri back in February of 2021, which actually brought down the central grid for a period of time. Now, the question is, can we identify geographic areas that have the political and public will to become truly energy independent? And these areas can include large companies, municipalities, universities, schools, and hospital complexes. Our goal is to establish 50 microgrids throughout Texas within the next 12 months. And I know it's an ambitious goal, but it's something that I think is really required if we're going to get our smart city situation under control, because the need for electricity is not going to decline with all the smart city desires. And microgrids, as I said, use any source of energy. It could be solar, including rooftop solar, and they connect to the central grid, and they need to have battery storage to really be efficient. They operate 24/7, 365, just like the ERCOT grid does. And they can link in, or they can be islanded, which means they can be isolated from the central grid. But most of the things that easy microgrids are going to do are not islanded. They're going to be linked to the central grid, and they're going to help transition from fossil fuels to renewable energy over a period of time. Hopefully that period of time will be within 30 years, but we don't really know that far in the future. So the easy microgrid can help transition away from fossil fuels. Here's an example of one microgrid that is based on renewable energy. You can see all the solar rooftop panels, and you can see the battery storage next to the big building on the left. So, like a smart city, the microgrid controller is the brain of the microgrid. It's a software-driven controller, and it distributes and manages and optimizes energy production, and it'll generate data analytics that are required by smart cities. It can, as I said, it can link to the existing grid, which is what we want to do, or in cases of like remote parts of West Texas, it could be islanded as a standalone energy source. For example, in the Hill Country, they have a lot of problem with Wi-Fi and broadband. Perhaps a microgrid could solve that problem with some 5G. It would be a good way to get the Hill Country much more connected, which I know is a desire of the city of Fredericksburg. The key to all this is utility scale battery storage, which over the past 5 years has improved so much that we can actually do these microgrids on a scale basis that we could not do 5 years ago. There are about 8,600 microgrids of at least 1 megawatt throughout the United States. So there is not an enormous amount of microgrids yet. That's why this is such a great business to scale so quickly, given what we need. So most of those utility scale batteries are going to be lithium, although zinc is also being explored as a utility scale battery storage medium. So there's these microgrids have been around. I believe UT had the first one in Austin, built back in 1929. But by 2028, which is about 6 years from now, there should be a $40 billion market. And with the volatility in energy prices and, you know, cyber attacks and storms and other threats, microgrids seem to be a really good way for companies and institutions to protect their infrastructure. Even during the pandemic, there were 560 microgrids built and installed in North America, and 2/3 of those were done as an energy as a service agreement. And that is the core business proposition for easy microgrids. We want to serve as either the developer of a microgrid or a consultant to the developer of a particular microgrid. The developer is the owner and operator of the microgrid. As a developer, we will finance 100% of the cost of the microgrid, either directly or through an affiliate. Then we enter into a 25-year energy service or energy as a service agreement. We used to call them power purchase agreements, where the end user is required to purchase the energy from the easy microgrid. We're going to purchase our equipment and operating expertise from very established industry entities like Siemens, Ameresco, Schneider Electric, and other proven vendors. We're not going to reinvent any wheels and get creative with that. We're going to standardize microgrids in order to scale the business. And that's very important, because by standardizing microgrids, we can plan ahead for the long term, but have the basics in place in as many locations as possible. And as I said, there are no front-end costs for the end user, and the ideal customers are called the MUSH market: municipalities, universities, schools, and hospitals. But I do want to add that industry and companies, especially tech companies that have data centers and distribution centers, large warehouses, are going to be very interested in the microgrid to provide a level of resilience for their supply chains, which we saw during the pandemic have been severely stressed. So the main thing is to compare the cost of electricity with the current source, identify renewable energy costs where possible. Like here in Texas, wind is very popular. We've been starting to see a lot more rooftop solar as well. Then we rank the reliability and the cost structure to maximize the sustainable benefits. We also have to maximize resilience, which was severely lacking in the last storm. So we really want to make our central grid more resilient. So basically, the end user has to be involved. The 25-year time frame has to be involved. We're going to be looking at serious capital reserves to make sure we're in touch with the long-term uses required by the users. So the basic ask here is we want people to help us identify projects and end users and sites for 50 microgrids of at least 5 megawatts in size. And we want to do this in the next 12 months. So the general rule of thumb is for solar projects, 5 acres for each 1 megawatt of solar energy are required. So a 5 megawatt site's going to need at least 25 acres of land. The financing of these projects is pretty conservative. You generally have about a $5 million cost for 5 megawatts, and 40% is considered equity with about a 10% return, and 60% is debt financing with about a 5% return under today's interest rate situation. With each of these sites probably being 25 acres, distressed shopping malls may be the ideal sites. And I did a quick survey. There are plenty of them throughout the state of Texas, these malls that are either dead or near dead due to the changing shopping patterns for online retail. So these shopping malls could be converted into EV charging stations and last mile distribution centers and data centers, and they could serve as hubs for smart city development. If you want further information, we really appreciate support because we're trying to scale this thing known as easy microgrids really quickly, because I think it's the right time, and we appreciate any assistance you can provide. So thank you very much, and I hope you enjoy our conference.